Here's a little nudge video for MOP WM7 in the waves unit. Well, I've chosen a question here that is one you'll see often and a skill that you have to be able to work with standing waves, and that is to describe how long the wavelength of a standing wave pattern is when you're given a diagram. So what we see here is a diagram of a standing wave, which is kind of hard to see because what your eye picks up when a rope vibrates very rapidly is actually the position of the rope at two different points in time. So if you look at one moment, what you'll see is crest, trough, crest, trough, crest, trough. So I just outlined that in red. But at the next moment, half a period later or half a cycle later, every crest has become a trough. So it actually starts trough, crest, trough, crest, trough, crest. And this is much easier to describe if we could describe a wavelength as just an entire crest and then an entire trough. So I'm going to outline this in green. Here is one wavelength outlined in green. So if we know the entire length of the rope, and in this case they describe it as 3.6 meters, so that's all the way across here. 3.6. So we're just asked how long that little green part is. Well, can you see how many of those fit inside the 3.6 meters? I outlined one here in green. Here's a second wave, and here is a third wave. So there are actually three waves on this pattern. One quick shortcut is to just take how many of the little, I call them football-shaped patterns, or the little humps that you see, and divide it by 2, and that's how many waves you're looking at. Because remember, you're looking at a crest and a trough kind of at the same time, hence the reason to divide it by 2. So in this case we have 3 complete waves in this 3.6 meters, so it's a simple division problem to get at the length of 1 meter, or the length of one wave rather. So hopefully that helps you on problems where you see diagrams like this. Any more help that you need beyond this, you just find me in the classroom.